Okay, so this worksheet, Equations in Education, is a continuation of word problems using real-world scenarios, and we're going to use equations and set up equations to solve these problems. So for this first one, it says the bar graph below shows the increase in elementary and secondary per pupil spending from 2005 to 2010. Elementary and secondary education refers to kindergarten through high school. Per pupil spending is the amount of money a school district spends on each student. Okay, and then we have our bar graph. Okay, the data is described by the mathematical model P equals 406.9t plus 8,795.7, where P is the per pupil spending. Okay, and for elementary and secondary students in the United States, and T is the number of years since 2005. Now, since 2005 means that 2005 is year 0. 2006 is 1 year after 2005. 2007 is 2 years after. 2008 is 3 years after. 2009 is 4 years after, and 2010 is 5 years after 2005. That's what that means, years since. Okay, so number 1. Use the formula to estimate the United States per pupil spending in the year 2008. Hint, 2008 corresponds to T equals 3, since 2008 is 3 years after 2005, and I just went over that with you, right? So we're going to put 3 into our formula where T is. That's what they're asking us to do. Okay, so we have P equals 406.9 times 3 plus 8,795.7. Okay, so we're going to do 406.9 times 3, and we get 1,220.7 plus 8,795.7. Add those two together, and you get P equals 10,016.4. Okay, so our per pupil spending is $10,016.40. That 0.4 means 40 cents. Okay, number 2. Let's use this model to make some predictions. We would like to know when per pupil spending in the United States will reach $15,000. To find this, set P equal to 15,000. Then solve the equation for T. Identify the actual year. Okay, so that's what we're going to do right now. Right, so we have P equals 406.9 T plus 8,795.7. That's our original question. They're telling us to put 15,000 where P is, so that's what I'm going to do. 15,000 equals 406.9 T plus 8,795.7. Okay, so if we used our flowchart method, we would have to do the opposite of 8,795.7. So that's what we're going to do right now. So we're going to do minus 8,795.7 on this side, minus 8,795.7 on this side. All right, so when we do 15,000 minus 8,795.7, we get 6,204.3. So I forgot my little wall there. Equals 406.9 T. Then in our flow chart, the next step that we would do would be to divide by 406.9. So we're going to divide 406.9, divide by 406.9. Okay, and we get T equals 15.25. All right, so that would be in the 15th year, because it's 15 years and a little bit. So it's asking us to identify the actual year, right? So remember, that's 15 years after 2005, right? So over here in our little corner, we have to add 15 years to 2005. So 2005 plus 15 years is going to be in 2020. That's the actual year that this is going to happen. Okay? All right, so moving on. Damn it. Okay, so moving on. Okay, moving on. In 2010, Connecticut was the 7th highest state in the nation in per-pupil spending. Connecticut's per-pupil spending from 2005 to 2010 can be described by the mathematical model P equals 690.4 T plus 11,634, where P is Connecticut's elementary through secondary per-pupil spending, and T is the number of years since 2005. So notice that P is Connecticut's per-pupil spending, but T is still the same. It's the number of years since 2005. Use the formula to estimate Connecticut's per-pupil spending in 2010. Well, 2010 is 5 years after 2005, so that means T is 5. So we're going to substitute 5 in where T is and solve. So we're going to have P equals 690.4 times 5 years. Oops. 5 years plus 11,634. Then we're going to calculate 690.4 times 5. This is 3,452 plus 11,634. Add those two together. So P is equal to $15,086 in Connecticut. Use the formula to predict Connecticut's per-pupil spending in 2014. All right, well, how many years after 2005 is 2014? If 2010 was 5 years after, then 2014 would have to be 9 years after. So we're going to do the same thing, except this time we're putting 9 in. So P equals 690.4 times 9 plus 11,634. 690.4 times 9. This is 6,213.6 plus 11,634. Add those two together and you get P is equal to 17,847.6. Don't forget this is money, so our answer is really $17,847.60 in per pupil spending. Okay, moving on to number 6. When will the per pupil spending in Connecticut reach $18,000? Identify the actual year. Okay, $18,000, identify the actual year. Remember, $18,000, that's P. So we're putting that where P is. And then at the end, we have to figure out what year that is. Okay, so we have to add it on to 2005. Okay, so let's do this. So our original equation is P equals 690.4 T plus 11,634. 18,000 is going where P is, so 18,000 equals 690.4 T plus 11,634. So if we were doing our flowchart method, we would have to do minus 11,634 first. So that's what we're doing, minus 11,634 minus, 11,634 so 18,000 minus 11,634, we get 6,366 is equal to, bring this down, 690.4 T. Okay, our next step would be to divide. So we divide by 690.4, divide by 690.4. Okay, and we get T is equal to 9.22. So just like in our last question, that's 9 years and a little bit more. So you're in the 9th year. So that would be like January is the start of the 9th year, so, you know, a few months in. So we now have to do that, identify the actual year part. Right, so over here, we're going to do that because we have to remember adding on to 2005. So 2005 plus 9 years is equal to, in 2014 is when we would reach that price. Okay, $18,000, which makes sense because if you look back at number 5, right here, we were close to $18,000 at the beginning of 2014, right? $17,847.60. So it would make sense that during that year we would reach $18,000. Okay, so at this point, you are going to finish doing this worksheet on your own. You need to be able to identify the unknown, right? So I will actually start number 7 off with you, and then you can complete the rest on your own. So in a recent year, the number of elementary and secondary students in Connecticut decreased by 3,800 students. If there are 543,000 elementary and secondary students in Connecticut, and the number of students decreases by 3,800 per year, how many years will it take for the number of students to fall to 516,400? Right, so we need to identify the unknown. Well, what are they asking us about? They're asking us about the number of students, right? So X is going to be, nope, they're asking us how many years will it take. So this is the number of years. Sorry, take that back. Right here, how many years? That's what they're asking us. How many years? That's how we know what the unknown is. So we're going to write the equation. So our equation is going to be, okay, if there are 543,000 elementary students in Connecticut, and the number decreases by that much per year, how long will it take for them to fall to this amount? Okay, so that's our equation. We're starting with 543,000. Decreases means we're subtracting 3,800 per year, and that total comes out to 516,400. So there's our equation using those numbers. Okay, and then you're going to solve that equation. Okay, and you can use your flowchart method or any method that you want to. Okay, so that's how you set it up, and then from this point on you should be able to do the rest of the questions. All right.